Good morning, guys. Welcome to today's lesson, April 9th, Central and Inscribed Angles. Please make sure you're in Module 5. That's where our lessons will be from here until the end of the year, most likely. We're not going to be working with Module 4 at this point. Make sure you have your own Module 5 section. You either copy it over or you make your own section and label it Module 5. But that's where I'll be checking your daily lessons to make sure you have everything taken care of. All right? So Module 5 from here on out. Today's do now. In scalene triangle ABC shown in the diagram below, the measure of angle C equals 90 degrees. Which equation is always true? Hopefully you picked choice 4. Sine of A is equal to cosine of B. When remember, A and B are two angles that add to 90 degrees. And when they're two acute angles in a right triangle, they have to add to 90 degrees. So for example, 60 degrees and 30 degrees. That would mean sine of, let's say, 60 degrees equals cosine of 30 degrees. That's just one example. Any combination of two angles that add to 90 degrees. So it could be something like sine of, 15 degrees. That would be equal to cosine of 75 degrees. All right, we can go on and on, but just remember these are cofunctions, and when sine and cosine are equal to each other. The next one. If triangle ABC is dilated by a scale factor of 3, which statement is true of the image triangle ABC prime? So think about two answer choices you can definitely eliminate. When a dilation takes place, the side lengths will change proportionally. The angles won't change, whether it's a dilation or whether it's one of your rigid motions. Angles are never changing. So choices 3 and 4 are out. So we have to decide between 1 and 2. The original triangle is going to get multiplied by 3. So which answer choice shows the original triangle multiplied by 3? That would be choice 2. Choice 1 is multiplying the image, the new image. No, we're multiplying the original, the pre-image, so we'd be multiplying triangle ABC. In this case, they're multiplying side length BC. All right? So guys, this is very new. Module 5 is all about circles. Okay, it says what are the different angle relationships within a circle. So we're going to basically be going through almost this entire worksheet in the video because it is so new and there's a lot of fundamentals we have to make sure are taken care of. But at any point, remember, you can pause the video and you can give the problem a shot on your own and then see how you did. Okay, but a lot of these beginning things, you're really going to have to pay attention and make sure you're taking all the notes. Okay, but parts of a circle to start. So a radius, right? We know what a radius is. It goes from the center of the circle and touches a point on the circle. All right. The diameter, also nothing new yet. The diameter goes from one point on the circle all the way to another point on the circle, and it has to pass through the center. Just like the radius has to hit the center, the diameter has to pass through the center. A chord goes from one point on the circle to another point on the circle, but doesn't have to pass through the center. Like I can make a chord like that. Okay, it touches the circle twice. It doesn't have to pass through the center, and it's totally on the interior of the circle. All right, a secant and a tangent I'm really just going to mention. It's not seen too much today, but it's good to know. The secant hits the circle twice, just like the chord does, but it expands into the exterior in both directions. Okay, and the exterior is just the outside of the circle. All right, a tangent only hits the circle one time. There's literally just a point. This is called a point of tangency. It's just hitting that point very finely, just one time, and then extends into the exterior, in both directions, goes on the outside of the circle. But the difference between the tangent and the secant hits twice, the tangent hits once. All right, and then up top here, we have an arc. So this right here, an arc. An arc is just a part of the circle, as you can see. And now, just like this angle on the inside here, or an angle's formed between the radius and another radius, or whatever it is, a radius and a diameter, there's an angle formed. Just like if I was to go out here and make an angle. All right, this angle, I don't know, maybe it's 40 degrees or something like that. Just like two lines come and meet and form an angle, an arc also has an angle measurement. All right, arcs, that's a big idea here. Arcs also have an angle measurement. And when you're thinking about, well, there's certain rules we're going to follow, but when we're thinking about how many degrees is in that arc, it's really a matter of what percentage of the circle is that, and you can kind of guesstimate how many degrees it is. In total, the whole circle, think about this, how many degrees is the entire circle? The entire circle is 360 degrees. So it's an arc. A circle, its arc's entirety is 360 degrees. So think about this. What if I went from here to here, that arc right there? How many degrees would that arc be? Well, that's half the circle. So that arc would be 180 degrees. If I went from here to right about there, how many degrees would that be? That's about a quarter, okay? So that would be 90 degrees. So there's different amounts of arcs. So like maybe it's this arc right here, okay? Maybe it's 60 degrees, 50 degrees, but it's good to be able to guesstimate how many degrees it would be based on what percentage of the circle is it. So the big idea here, guys, just like normal angles that we know when two lines come and meet, arcs also have angle measurements. All right, we're going to learn some rules today about how to find the measure of certain arcs. All right. So, central and inscribed angles, those are the two main ones today. All right, what is a central angle? Well, it's essentially an angle that's formed by two radii. All right, it's formed by two radii, so it's a radius, two radius of the circle coming and meeting. And where do they meet? The central angle. All right, where do they meet? They meet at the center. So the vertex is at the center of the circle. And it would also be good to jot down that it's made from two radii. Right? This is a radius right here and right here, both radius. Okay. So what's the rule? All right. Now, an angle when it's formed. So if I make this angle with the two radii there and there, that angle that's made, which would be right there. There's an angle inside the triangle. Inside the circle. Now the arc that it opens up, this angle opens up and hits an arc. Okay? That arc right here, that the angle opens up and hits, that's called the intercepted arc. It's the angle's opening up and hitting that arc. That's called the intercepted arc. So, the central angle is equal to the measure of the intercepted. So that's kind of like intercepted arc. That's the new vocabulary. Intercepted arc is just the arc that's being hit by the two lines. The two lines open up and hit an arc. All right, that's called the intercepted arc. So here, the measure of x, that angle, the central angle, is equal to the intercepted arc. Right now, the intercepted arc is 80 degrees, so the angle on the interior is also 80 degrees. All right. Now, next, an inscribed angle. Think about where the vertex is for an inscribed angle. All right, the vertex is a point. Remember, the vertex is where the two lines come and meet. where the two lines meeting right now. The vertex is a point on the circle. Alright, the vertex is a point that is on the circle. What is it made from? This would also be good to jot down. Okay, before it was 2 radii. Now what's forming this angle? Alright, well, if you think about what these two lines are, that line, what is that called? And that line, what is it called? Okay, those are chords, so it'd be two chords. Now it could be, that's just usually, it could be a chord and a diameter, for example. Alright, but generally it's 2 chords. Alright, and now the rule. So first off, once again, this angle, the two lines, this angle, as the angle opens up, let me show you it this way. The angle opens up to here and to here, and it hits an arc. So this arc right here that it opens up and hits, that's called the intercepted arc. All right. The inscribed angle is equal to 1/2 the measure of the intercepted arc. Now I could write this another way. I could say the intercepted arc is equal to double the measure of the inscribed angle. All right. But right now the inscribed angle is equal to half the measure of the intercepted arc. The arc that it hits is 100 degrees. The inscribed angle is equal to 50 degrees. But they could have given me the 50 and asked for the 100. It depends. What are you being asked for? You asked for the arc, or you asked for the inscribed angle? Right now the inscribed angle is 50. The intercepted arc is 100. So remember what that intercepted arc really is. Now I don't want to spend too much time on a tangent chord angle, but essentially what a tangent chord angle is, it's made from a chord right here. That's a chord, and it's made from a tangent. BC right now is a tangent. It's the exact same rule that's applied for an inscribed angle. And you think that kind of makes sense because it's made, the vertex is a point on the circle, just like it is for the inscribed angle. Alright, so same rule for the inscribed angle. The tangent chord angle is equal to half the intercepted arc. Right now the intercepted arc is equal to 120 degrees. So this angle, the tangent chord angle, would be equal to half of that, which is 60 degrees. Alright, let's see how these problems look. Now, AD and CG are diameters of circle B. Find the measure of each of the following. So they're asking us for a bunch of arcs. This is the symbol for arc, the measure of arc CD, the measure of arc AC, the measure of arc GF, and so on. What they gave you here, guys, is some central angles. I know it doesn't look like they're central, but this right, the 55 degrees is right there. The 35 degrees is right there. All right. So let's start with A, arc CD. So arc CD is right here. That's equal to the central angle. Remember, the arc is equal to the central angle. So this arc right here would be 55 degrees. All right, the arc and the central angle are the same. All right, now, next, the measure of arc AC. So this was the 55. Let's take a look at arc AC. Now, that arc right there in green is equal to what this angle is here, because that's the central angle. We could find that angle with a linear pair. So what's the linear pair with that 55 there? See that right there? That's a straight line. This is a diameter. All right. We have a linear pair, two angles that are next to each other on a straight line. So this would be angle ABC here, basically where that letter B is exactly. That angle would be 125 degrees. Okay, so that central angle is 125. The intercepted arc would also be 125. Next, arc GF, which would be, let's just switch up the colors here, right there. So that central angle is equal to 35 degrees. This would also be equal to 35 degrees. Arc GF is 35. Guys, this is just repetition of a central angle and the arc that it intercepts. They're equal to each other. All right. Now, arc AG. What would the measure of arc AG be? Well, it would be helpful if we had this angle here. If we knew that angle there, then we know what AG is equal to. You can find it. Guys, we have vertical angles right now. All right, with the 55 degree angle, this would also be equal to 55. Vertical angles are congruent. So the arc for AG would also be equal to 55 degrees. Alrighty, and finally, let's take a look at arc DF over here. For arc DF, we need to know what's this angle here. Alright, once we have that angle there, now in total, you could take 55, 125, 55, 35, and that set it equal to 360 degrees in total. Remember, when you go all the way around, we have 360 degrees. But what would that x be? You could do a linear pair, or more of like a linear bunch for 55, 35, and x. Those three together are on a straight line. Remember, the diameter is a nice straight line. So those three together, 55, 35, and something, equal to 180 degrees. So this angle here would be 90 degrees. You can check to make sure all those angles on the interior there add to 360, and they do. That arc would be 90 degrees. All right, so let's move on here. Given the measure of angle DEF is 38 degrees, so let's fill that in. DEF, 38 degrees. DE is a diameter. Find the measure of arc FD, the measure of arc EF, and the measure of arc DE. So FD is here. Let's think about what is angle DEF there. What type of angle? Is that a central angle? Does it meet at the center? Nope, it meets on the circle. All right, it meets on the circle. So the relationship would be it is equal to double the inscribed angle. Remember, the inscribed angle is half. The arc is double. All right, so this would be 76 degrees. Now, the arc EF from here. Might be a little bit confused about how are we going to find that? Because this in total, all right, if you look at the entire section from D all the way around to E, that's half of the circle because it's split by the diameter there. That's half of the circle, so we have 180 degrees in total. So if we did 180 minus the 76, we would get 104 degrees. And then arc DE is here to here. You guys, DE itself, not the arc. Let's just look at the line, the segment DE. That's the diameter. That's half the circle. So the arc that it intercepts has to be the exact same thing. All right, DE is half the circle. Now let's look at the arc. From D all the way around E, that's half of the circle, so that's 180 degrees. All right, it's new. It's new. It might be a little confusing right now. These are things you'll master very quickly. All right, next, given the measure of angle MOP is 88 degrees. MN is a diameter. Remember, that's important because that splits up as half the circle. There I'm saying MN is a diameter, so we know the arc there would have to be half the circle, 180 degrees. Remember, a diameter splits the circle into two equal parts. All right, so I'm not even going to look right now at what they're telling me to find. I'm just going to find it, all right, and we'll hopefully accomplish the goal here. All right, so we have the 88 degrees on the inside there. Now, there's a linear pair. There's an angle next to 88, right? Linear pair, those two angles have to add to 180. So this angle here would be 92 degrees. Now, the arcs that they intercept, for example, let's look at MP. That's equal to the central angle. So this right here would be 88 degrees. Now our arc over here, PN, that's also equal to the central angle, 92 degrees. All right. So we found a bunch. We have MP, right? Arc MP is equal to 88 degrees. Arc MN, 180. Arc PN, 92. Angle PON, that's one of the central angles. Angle PON, 92 degrees. Angle NMP, where's that? NMP, right there. Okay. Well, angle NMP, what type of angle is that? It's an inscribed angle. So let's switch out colors here. NMP. So the arc that intercepts, guys, is PN. Okay, those two lines open up from that angle X. M opens up to N, M opens up to P. It hits this 92 degree angle there. That arc. So this is an inscribed angle. It's equal to half of the arc it intercepts. So what's half of 92? That would be 46 degrees. All right. Now, angle MNP. MNP is sort of the same thing going the other way, guys. Ready? M and P. Right? That opens up and hits the 88 degree angle. But so MNP is not 88 because it's not a central angle for angle MNP. The arc, it's equal to half of that arc of 88, so that'd be 44. And finally, angle MPN. So MPN, that's this angle here. Let me take out some of this inside stuff. Let's fill in what we have. We found that this was 44 degrees. This is 46. So what's the measure of MPN? So MPN is this angle here to there. Now what you could do, you could find this angle there. Three angles of a triangle, 46, 88, and what makes 180 degrees, so try that out. So we get 46 degrees here. All right. 92 On the other side here, this unknown, 92, 44, and what makes 180? So this would also be 44 degrees. Now, I don't want to get too much into this, but why that works? These are isosceles triangles because they're made from radii. So this and this are equal. So it's 46, 46 is those base angles. This and this are equal to each other. So it's 44. The base angles are equal. We have 46, 46 and 44, 44. However, what they just asked for, they asked for MPN, which is this whole piece there. So it's the sum of 46 and 44. That would be 90 degrees. Those two together. All right, let's move on. A couple practice problems. Remember, at any point if you want, all right, at any point you can pause, try it out on your own. So, given circle with center indicated, find x. All right, so they give you some arc here, 70 degrees, and there's an angle. Right, this is a central angle right there, so that would be equal to 70 degrees. Remember, these are radii, this and this. A central angle is made from radii, so the base angles are equal. So that x there, this is also x. X and x are the exact same thing. The base angles would be equal. So we would have x plus 70 is equal to 180 degrees. Right, we have three angles of a triangle. Basically, we just made an isosceles triangle in there. All right, so you can solve that. You would end up with 55. First choice. We had to know that the central angle was equal to the intercepted arc. Okay, next. 4. We have to find x. We're given a diameter again. So this arc that they gave us is 56 degrees. This arc with that in green, so there's green and the blue arcs, those two have to add to 180 degrees because it's half the circle. All right, so what's 180 minus 56? Be 124. And this arc over here would be 180. That's half the circle. The left side of the circle, it's literally half, exactly half the circle. So that'd be 180. Now this arc for x, look at how x opens up. This angle goes to here and here. So this is an inscribed angle. It meets on the circle. So that x value there is equal to half of the intercepted arc. What's half? All right, what is the intercepted arc right now? It opens up to that 124, the green arc here. So we have the 56 over here, that arc. We needed that to find the 124, but here's our focus. The green arc right here, the 124. So the inscribed angle is equal to half of that. Half of 124 is equal to 62. All right. Next, given circle with center indicated, so we have a center. All right, that 50 degrees, that's an inscribed angle. It meets on the circle. Now, the 50 degrees, the two lines that open up, these two chords, boom, open up here and here. So the intercepted arc would be this right here. So now you might make the mistake for the first time and say, okay, that's 25, because it's half, right? Inscribed angle half. No, the inscribed angle is the 50 right now. The arc is double. So this arc would be 100 degrees. Remember, the inscribed angle is equal to half of the intercepted arc. So right now we kind of have to work in reverse. All right, so 50 and 100. Now x here. Is this and this, so they have the exact same intercepted arc. This is really good to see. 50 and x right now have the exact same intercepted arc. The 50 opens up and hits that arc of 100. The x opens up and hits that arc of 100. So x here now is a central angle that's equal to 100 degrees. So be choice 3. This is good to see. The inscribed angle, 50, right, that's half the intercepted arc. The central angle, 100, is equal to the intercepted arc. Next. All right, given diameter AB, find x. Now this is a relationship you can memorize. It'd be good to, for sure. But AB is a diameter. That's half the circle. So right here we have 180 degrees. Half the circle, 180 degrees. Now, when we're inscribed, this is an inscribed angle in a semicircle. Here's what I mean by that. This line for x, this angle of x, opens up here and opens up here. That opens up and intercepts an arc. That's exactly half the circle. So this is called an angle, and you can Google it or whatever you want to do, an angle inscribed in a semicircle. Semicircle is half of a circle. So this angle for x, right, opens up, hits that 180 degree angle, so it's equal to half of the intercepted arc. So 180 degrees is the arc, the angle would have to be 90 degrees. Alright, so once again, this is an angle. It opens up. It's a normal inscribed angle. Same rule for an inscribed angle. It's just unique because this angle opens up. It's inscribed perfectly in half of a circle, which is a semicircle. So the intercepted arc is 180. Half of that is 90. Now another unique rule. This could be a lesson in and of itself. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So you can see the diagram here. What they're showing you is that A and F, right? A and F are opposite each other. Those are supplementary. They add to 180. And then B and E are opposite each other. They're supplementary. They add to 180 degrees. When is this the case, though? It's when the quadrilateral is basically in the circle. Okay? It's when the quadrilateral is inscribed perfectly. All four vertices of the quadrilateral are points on the circle. So right now, let's say x, right? X, this is inscribed, right? Given a circle with center indicated and inscribed quadrilateral. X is opposite the 105, so this would be 75. They have to add to 180 together. And then 86 and y, they're opposite each other. Those two have to add to 180. So y would be 94. This would be choice 1. All right, 2 more. Given a circle with center indicated. So, remember, at any point you can pause the video. So what you have to see, 9's a bit challenging. Remember this triangle here that's formed, it has a central angle right there. Right, that's a central angle. Remember, it's formed from 2 radii. So this right here, that's a radius, that's a radius. So that essentially makes this an isosceles triangle. So we have 2 base angles that are equal to each other. So we'd have that 50 degrees you see bottom left. Bottom right would also be 50 degrees. So this is just us filling in what we know. We see something, we can fill it in. Now 3 angles of a triangle can get us the central angle. The central angle, so 50, 50, and 80. comes to 180 in total. Now the intercepted arc for that 80-degree angle, remember it opens up here, here, it opens up and hits that blue arc there. So this would also be 80 degrees. Remember the central angle of 80 is equal to the intercepted arc of 80, 80 and 80. Now the inscribed angle opens up and hits the same arc. So we have the same intercepted arc of 80, however we have a different relationship. The inscribed angle is equal to half of the intercepted arc. So this angle right here would be 40 degrees. Half of that 80, choice 4. And finally, definitely you should try and pause this one. Try it out on your own. We're looking for x. Remember, we have a diameter again. So is this going to help me? I don't know. Look, if we know something, we should fill it in, just like any type of angle problem for Module 1 or Module 2. If you know something, fill it in. That's half the circle because it's split by the diameter. We know that this is 180 degrees. All right. They gave us this 37 here. Remember, that opens up and hits this arc over here. So that arc is equal to double the inscribed angle. So 37 times 2 will give us this 74 here. All right. So the remaining arc, so 74, and this right here, the other half of the circle, 74 and what makes 180? This would be 106. And x, that's its inscribed angle because x opens up and hits 106 for the intercepted arc. And x is equal to half of that 106, which would be equal to 53. Choice 2. Alright guys, so I expect a bunch of questions today. This is very, very new. There's a lot. I would watch this video a couple times. Go back, try some of these on your own. Make sure it makes sense. Ask questions and remind. In addition, your Delta Math is due tonight at 8 o'clock. And that's really it. Please send me questions. I understand it's new. Remember, these are the two major rules for today, the central angle and the inscribed angle. The central angle is equal to the arc. The inscribed angle is equal to half of the arc. All right? Have a wonderful rest of your day. I look forward to hearing from you throughout the day. And I'll see you mañana.